So the next thing that we have to learn with regard to quadratics and solving them for the Algebra 1 Common Core is the quadratic formula. And the reason as to why is because it's one of the learning standards. So the essential question is, how and why do you employ the quadratic formula? Well, the how is you're going to be provided the quadratic formula in the back of your Regents exam. So I'm going to show you in this lesson how to use it. And the why we need to employ the quadratic formula is because in some cases it's better to use the formula in order to solve, especially when there's a coefficient greater than 1 next to the squared term, which I will show you in a minute. You were not taught how to factor those types of equations, which I am going to do an example of one like that. I am going to factor it, and if you're able to pick up on it, that's great. But if not, you have the quadratic formula to use, and you have to use it and know how to use it. Anyways, additionally, you would want to use the quadratic formula if you don't or you have an unfactorable quadratic, and in some cases that may be, and if you can't factor it, then quadratic formula is always good to use. So you've been factoring in the past to solve quadratics, and if you look at the first one here, your coefficient of the squared term is 1, and if that's the case, you're going to look at the last number, 72, and figure out factors of 72 that also have a sum of the middle number, 17. And we know that 9 times 8 is 72, and 9 plus 8 is also 17. So those are going to be my factors. They're both positive in the factors. But when you set them each equal to 0 and solve, you're going to get the opposite values. So that's one way in which to solve a quadratic equation. Another type of quadratic equation is when you have that coefficient that is greater than 1 next to the squared term. And it is factorable. We just don't teach you at this level because we just don't have enough time to get to that. But if you were to factor it, you would look at factors of negative 12, and you would just plug in. They're not going to have a sum of 5 because this 2 is going to change things up a little bit. So I'm going to go with 3 and 4. And if you multiply 2x and 4, you're going to get 8x. And if you multiply the inside 3x, you can find the sum of these two, 8 and 3, which you're going to get an 11, but the difference will give you 5. And the only thing we're going to have to do is figure out what the signs are. So if we made the 4 negative, 2x times 4 would give us a negative 8x, and then if you add that to a 3x, that would give us a negative 5x, and we don't want that. But what we do want is a positive 5x, and in order to get that, we would need the 3x negative. So I'm going to have 2x minus 3 and x plus 4 in order to get my positive 5x when multiplied and finding sums. So then we take each of the set of the factors and we set them equal to 0, just like we did in the other factoring situations. So we have 2x minus 3 is equal to 0, and we also have x plus 4 equal to 0. If you add 3 and divide by 2, we're going to get a result of 3 halves, which is also known as 1.5. Okay, and you could give the answer as each. And then you're going to subtract 4 from both sides here. We get a nice number of negative 4. So my values for x are equal to, I'm going to leave it in as a fraction form, but just know you can get the decimal equivalent in case you're asked for it. 3 halves and a negative 4. If you want to learn how to factor these, come in after school, and I would definitely show you how to do that. It takes a little practice, but I'm going to also show you how to use the quadratic formula in order to find the same results, and that's the main reason as to why I'm doing this here at this point in time. So the quadratic formula is an alternative method in which to solve quadratics, and you can solve any one of them. But as you can see, we have some with fractions, and which we've only been able to factor things that have rational roots. Now we can go into finding irrational roots and maybe even complex numbers, imaginary roots, if you get a negative under the radical. So you're not going to understand what this means right now, but later on you'll see. So here's the formula that is given to you in the back of your Regents exam, so you don't have to memorize it. You just have to know how to use it, and you have to be able to transfer it from the back of the Regents exam to your paper that's before, that comes before your formula sheet in the back of the Regents. So the first thing you need to do is have your quadratic equation in standard form, and it looks like this. Okay, so when you put numbers in for A, B, and C, they're going to be represented by the numbers given in the quadratic equation. So we have 2 is representing A, 5 is representing B, and C is represented by -12. So I'm going to write this off to the right here. Okay, keep track of the signs. Always look to the left of the numbers. Make sure you got the signs correct. So using those values 2, 5, and -12, I'm going to substitute them into the formula. So it's x is equal to -b plus or minus square root b squared minus 4 times a times c all over 2 times a. So my value for b is 5. I'm going to plug it into -b, so it's -5 plus or minus b squared is 5 squared minus 4 times a, which is 2, times c, which is -12, all over 2 times 2. So then I'm going to simplify what's under the radical first. So I have -5 plus or minus, I have 25 plus 96. All over 2 times 2 is 4. Then I'm going to find the sum of what's under the radical. So 25 plus 96 is 121 all over 4. The square root of 121, that's a perfect square, so it's equal to 11. So -5 plus or minus 11 divided by 4. And here's where I'm going to split these two values up. So I get -5 plus 11 over 4, and I also get -5 minus 11 over 4. And this is how we're going to get our two values. Okay, this little 2 up here in the quadratic tells me I'm going to get two values. So plus and minus represents that, and then at the end we split them up in order to get the values. So -5 plus 11 gives me a difference of +6, so it's 6 divided by 4. And that reduces to 3 halves. And the bottom one gives me a -16 divided by 4, and that gives me a result of -4. So my two values for x were 3 halves and -4, which we already knew because we factored it earlier. So this is just to show you how we get the same answers using a different method using the quadratic formula. So here are the steps in which we just did. So the first step is to calculate what's in the radicand. We're going to work from the inside to the outside, very similar to order of operations. And then the third step is to combine what's left in the numerator. And the final step is to divide and then simplify any further. So here's the next example. So we're going to pick out our A, B, and C. So I would write that over someplace to the left or right of your paper. In this case, I have it listed to the left, but you're just going to be given the quadratic, and you can write it wherever you'd like, but at least write it. So A is 3, B is 7, and C is 2. So the quadratic formula is x is equal to -b plus or minus square root b squared minus 4ac all over 2a. So now let's plug in our numbers. X is equal to -3 plus or minus 3 squared minus 4 times 3 times 2. And that's all over 2 times 3. So x is now equal to -3 plus or minus, let's do everything under the radical sign. So I'm going to get 9 minus 12 times 2 is 24. All over 6. Oops, I got off track there a little bit. Sorry about that. So x is equal to negative b, that's going to be a 7. My bad. We would have gotten a negative under the radical, and if we did get that negative under the radical, that would be an unreal answer. We call that imaginary. So this is not a bad thing that this happened at this point in time, because mistakes happen. But at least I was able to go back and fix it. So if we did get a negative under the radical, just know that you would end up with an unreal answer, the imaginary unit, and that is something that you have to know for the Common Core Regents. We don't see it too often, but know that it happens. So I'm going to go back and put the correct value for b because it's negative b. So that's a positive, nope, that's a negative 7. And then it's 7 square over here. So I'm going to end up with 49 down here. It's still negative 7 out here. And if I subtract 24 from 49, I get 25. So x is equal to negative 7 plus or minus 25, all divided by 6. And then I'm going to get negative 7 plus or minus 5 divided by 6. And then I'm going to have to split them up in order to get my two roots, also known as my two zeros, also known as my two solutions. So my values for x are negative 1/3 and negative 2. Okay, that's where this graph were to hit the x-axis, don't forget. Moving on. Okay, so what happens when I have a quadratic and it's not equal to 0? Well, you have to get it equal to 0. So I'm going to move the 11x over by subtracting it, but I have to make sure it's in the correct spot because we have to have this in standard form in order to solve using the quadratic formula or even to factor. So we have 2x squared minus 11x, then the plus 5 because the constant always goes at the end. And then I'm going to do my a, b, and c. So a is 2, b is negative 11, and c is positive 5. And then I'm going to write the formula. X is equal to negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. And I'm going to plug in. So x is equal to a negative 11 plus or minus negative 11 squared minus 4 times a, which is 2, times c, which is 5, all over 2 times 2. Now we're going to start working under the radical and simplifying other areas as well. So a negative times a negative is going to make this a positive 11. It's still plus or minus. And I have negative 11 squared, which is a positive 121, minus 8 times 5 is 40. And that's all over 4. Do the math under the radical, so it's 11 plus or minus 121 minus 40 is 81 divided by 4. And then it is 80, square root of 81, that's a perfect square, so that's going to simplify to a 9. And then we can split this up. So we have 11 plus 9 divided by 4, and we also have 11 minus 9 divided by 4. So this gives me 5, and this gives me 2/4, which reduces to 1/2. So my values for x are 5 and 1/2. Okay, so these have worked out very nicely. What happens when they don't work out nicely? What happens when we get an irrational result? We can either give a simplified radical answer, or we can get the decimal from that simplified radical answer. So let's find the zeros of the following quadratic. So the quadratic is x squared is equal to 6x plus 1. In simplified radical form, as well as to the hundredths place. The first thing that I would do is evaluate whether or not my quadratic was equal to 0. In this case, it is not, so I'm going to get it equal to 0. So I'm going to end up with x squared minus 6x minus 1 equal to 0. Then I'm going to pick out my a, b, and c. So a is 1, b is negative 6, and c is negative 1. And then I'm going to write the quadratic formula. And I'm going to write it correctly. Okay, so x is equal to negative b plus or minus square root b squared minus 4ac all over 2 times a. And then I'm going to put in my substitutions. Okay, so for b, I have it being represented as a negative 6, so it's x is equal to negative 6 plus or minus square root negative 6 squared minus 4 times a, which is 1, times c, which is a negative 1. And that's all over 2 times a, which is 2 times 1. And we're going to do the math. So x is equal to a positive 6 plus or minus. Now keep in mind, if you put in the calculator negative 6 squared, it's going to give you a negative result. And we all know that a negative times a negative makes a positive. So if you put the negative 6 in parentheses and then you square it, you're going to get a positive 36. So make sure this value is positive. That's the whole purpose in doing this. And then you're going to get plus 4 all divided by 2. And then we're going to find the sum of 36 and 4. So x is equal to 6 plus or minus 40 all over 2. And then radical 40 simplifies to, because that's not a perfect square, it simplifies to, if you break it down to 4 times 10 and you take the square root of 4 and 10, you're going to get 2 radical 10, all divided by 2. And that simplifies even further to 3 plus or minus radical 10. Okay, so you can divide out the 2's, the denominator of 2 into the 6 as well as the 2 in the numerator. Okay, so that's simplified radical form. In order to get this same answer rounded to the nearest hundredths place, you're going to have to put some of it in your calculator. So you're going to split it up. So x is equal to 3 plus a radical 10. Simplified radical form. And then you're also going to split it up to 3 minus radical 10. And you're going to put that in your calculator and get the approximate value. So 3 plus a radical 10 in the calculator approximately equals to 6.16 rounded to the hundredths place. That's the spot right here. And 3 minus a radical 10 is approximately equal to a negative 0.16, and again to the hundredths place. If Regents asks you to do that, put it to the hundredths place, and you get just 3 plus or minus radical 10, they will not give you a point for that. So just make sure that you're able to give the answers in both ways. The last thing that I would like to talk to you about, which doesn't happen often, like I said, but they do want you to be able to understand the differences between the types of results that you may get. When you have something with a perfect square, a number comes out nicely for it, which is 11. When you have something like the radical 40, which you saw earlier, you can simplify that, and then you get 2 radical 10. However, when you get a negative under the radical, and potentially that could happen, so anytime there's a negative under the radical, this would be called an imaginary non-real number. It's got the imaginary unit in it. And graphically, what that means is if you were to put that quadratic that was given and you did the quadratic formula, but you put the original quadratic equation into the calculator, you would have no points of intersection with the x-axis. So graphically or picture-wise, that's what that would mean. Okay, so know the difference between getting a real number, getting an irrational number, and getting a non-real imaginary number.